Hi guys, this is the neuroscience channel. Today we are gonna do the process of rectilinear propagation. You might have heard the word rectilinear in your maths teacher class because there are things like rectilinear lines and all. So now let's see what is rectilinear propagation. Rectilinear propagation is when you focus the light into one ray, like if you have a laser, like laser toys are everywhere in India, UAE, everywhere, and you get it very cheap. It's nothing but LED, battery, and a bunch of concave mirrors. Concave mirrors are nothing but mirrors which are like in the middle it's thin, and in the outer part or the boundary of the mirror it's thick, and in the middle it's thin. What happens is that the light somehow gets reflected and goes to the middle part which is thin, and then because of the transparency of the glass it goes straight. Instead of spreading, it will go straight. And also convex. Convex is the opposite of concave. Concave is nothing but when the middle part is thin, but in convex the middle part is thick and the outer part are thin. If you see, I have some kind of thing over here. It is the method 2. I will show you afterwards. When you see that through a convex mirror, this small thing which you can't even see properly will be as big as the mobile. So guys, let's see first of all what's a concave mirror. Concave mirrors, yes, I told you, but what else thing we can be used it for? For example, a laser. Mostly lasers are used for things like cutting a thermocol sheet. It's used during like aerodynamics things which we need a proper cut, even a small thing which can affect the plane and make it just. I have a very good advantage of the aerodynamics, but I still not did because of the less things and all. But I will do it and show you guys what it is. But before that, let's see what's a rectilinear propagation. When the light hits on the boundary of the part, it gets focused to the middle, and some directly hit the middle and makes a concave mirror, making a laser. This laser waves hit on the area and making one single line. Not even you can see a thing. Like if you use a laser to see things, you'll see what everything is dark except for the laser part, being part. I was like, oh my god. So now lasers are mostly used, as I told you, cutting thermocols and popping balloons and tricking people. Like when you use a laser and keep it in front of a pink balloon, what happens is that the pressure, or we can say the heat given, pops the balloon. But it cannot be done in red balloons because they have more density. If we use pink or green color, it will be less heater or denser, which cannot pop red, but it can pop its color itself. So today let's see what's the process of rectilinear propagation. And now, as we have learned the method 1, let's learn the method 2. Let's see what's the method 2's example. This is how it looks. This is the machine which is mostly used. So now let's see what it is. And now you can see me like this. Now let's see what's the method of blocking light. As you can see down over here, we can see that the torch, or you can see a torch, yeah, it's a torch, lighting and going in different waves, or we can say rays. These rays get multiplied and they get into 1, 2, 3, 4, 5. There are a million rays. Sun is one of the best source of light. So now the torch over here is the source of light. Next, you can see one ray is just going through the two holes in the cube. That's the process which I showed. Did you see that there are two cubes in the front and a plate in the bottom? These plates are very useful. they keep the two cubes stable. When the light goes through the two holes, it hits in an area in which you will see it get focused. So now let's see the picture for a while. I think that was a good look. And today we learned that what is a concave method of the rectilinear propagation and another method of blocking the light and making a laser, or we can say a rectilinear propagation. Thank you guys. If you like, please subscribe and click the bell button. I hope you liked it. Thank you.